We're on lesson 4 of chapter 6, which is to solve linear systems by multiplying first. So first we're going to multiply one equation, then add. Then we're going to multiply both equations in a system, then subtract. Then we'll solve a real-world problem. If you remember our last lesson, we learned how to solve systems by adding or subtracting. The problem is it's not always that simple. Sometimes the adding and subtracting, you can't eliminate what you need to eliminate. Like this one, for example, we have 5x plus 2y equals 16. 3x minus 4y equals 20. There's nothing that matches in this area. But that doesn't mean you can't get a little creative. For example, I know that 2y is half of 4y. So if I multiplied everything times 2, this would become a 4y, then I could solve it. So for example, I could have 10x plus 4y equals 32. And underneath it, I would have 3x minus 4y equals 20. Now I have the 4y's that I could add here. Right? So 10 plus 3 would be 13x. 4y plus negative 4y would be 0y. And then 32 plus 20 would be 52. Divide both sides by 13. And then x would equal 4. Now that I know that x equals 4, I then can solve for y like we've always done before. Let's try with the top one. 5 times 4 plus 2y equals 16. 20 plus 2y equals 16. Subtract 20 from both sides. That would be 2y equals negative 4. And if I divide both sides by 2, that would be y equals negative 2. And then I've solved my system by multiplying first, then doing my adding and subtracting. Let's solve this linear system then. We have 6x plus 5y equals 19. I have 2x plus 3y equals 5. Usually you want to see if one divides really easily into another. For example, this one does. If I multiplied this second one times 3, the 6's would then line up. So let's do that. We have 6x plus 5y equals 19. On the bottom, I could have 6x if I multiply that times 3 plus 9y equals 15. Subtract. This would be a subtracting one because we have a positive and a positive. Therefore, 5 minus 9 would be negative 4y, and then 19 minus 15 would be 4. Divide both sides by negative 4, and then I would have y equals negative 1. Then I could plug in the negative 1 for y on this equation, so 2x plus 3 times negative 1 would equal 5. So 2x plus negative 3, or 2x minus 3 equals 5. Add 3 to both sides. Then I would have 2x equals 8. Divide both sides by 2. Then x would equal 4. So y equals negative 1, x equals 4. So my coordinate point would be 4 and negative 1. Now we need to multiply both equations and subtract. For example, I can't multiply the 3x times a whole number to get me 4x, and I can't multiply 2y times a whole number to get me 5y. So I could find the least common multiple and then multiply both of these to get that multiple. First, let's line these equations up. Let's turn this into standard form like this one here. So we would have 4x plus 5y equals 35. Then we subtract this 3 from both sides, so I have negative 3x plus 2y equals negative 9. Let's turn the y's both into 10 because that's the least common multiple for these two. So I would multiply this group times 2. I would multiply this group times 5, and then I would get my answer. So this multiplied times 2 would be 8x plus 10y equals 70. This one multiplied times 5 would be negative 15x plus 10y equals negative 45. So since I have a positive and a positive, I need to subtract here. So let's subtract. 8 minus negative 15, so it's like adding 15, would be 23x. Then the y's would cancel out because I'm subtracting 10y. And that would equal 70 minus negative 45, which is like adding 45. So that would be 115. Divide both sides by 23. 115 divided by 23 would be 5. So x would equal 5. So now that I know that x equals 5, I could plug that into one of these equations here. Let's do this one right here. So we would have 2y equals 3 times 5 minus 9. 3 times 5 is 15, so 2y equals 15 minus 9. 2y equals 6. Divide both sides by 2. Therefore, y equals 3. So I have x equals 5, y equals 3. That would be my answer to this system, which would be 5, 3, and a coordinate point. Let's solve a real-world problem. Darlene is making a quilt that has alternating stripes of regular quilting fabric and sateen fabric. She spends $76 on a total of 16 yards of the two fabrics at the fabric store. Which system of equations can be used to find the amount x in yards of regular quilting fabric and the amount y in yards of the sateen fabric she purchased? Solve the system to find the amounts. So I see that x stands for regular quilted fabric. Then I see that y stands for the sateen fabric. I see that sateen fabric costs $6 per yard. I see that quilting fabric costs $4 per yard. Well, first of all, she needs a total of 16 yards. So if you add up the total of regular fabric with the sateen fabric, that would give you 16. So let's go x for regular plus the y for the sateen equals 16. That's our first equation. Now I see that the quilting costs $4 per yard, the sateen costs $6 per yard, and she spends a total of 76. So therefore I would write 4x because it's $4 per yard, plus 6y because it's $6 per yard of sateen, and that equals the $76. Here are my two equations. I can get rid of either the x or y by multiplying here. I'm going to multiply this times 4 to get rid of the x's. So 4x, because that's multiplied times 4, plus 4y equals 16 times 4, which is 64. On the bottom, I would have 4x plus 6y equals 76. This would become a subtracting one here. If I subtract 4x minus 4x, that would give me nothing. So 4x minus 6y would be negative 2y, equaling 64 minus 76 is negative 12. Divide both sides by negative 2. And then y would equal positive 6. Negative 12 divided by negative 2 is positive 6. So y was the sateen. So that's how many yards of sateen she purchased. Now let's find out how much of the regular amount she did. So I know that x plus y equals 16. If y is 6, I can then do x plus 6 equals 16. Subtract the 6 from both sides. So x would equal 10. So that'd be 10 total yards of regular quilting cloth. So if we're going to write that out in words, we'll say 10 yards of regular quilt and then 6 yards of sateen quilt.